Hi students, I hope everyone is doing well. Today's topic is oxidation of glycol. Let us see how oxidation takes place in glycol step by step. First, you should have the idea about oxidation. What is oxidation? It is either addition of oxygen or removal of hydrogen. That is, this is oxidation. Then to carry out the oxidation reaction, you need oxidizing agent. What is an oxidizing agent? Oxidizing agent oxidizes the other compounds and itself undergoes reduction. So you should have idea about the oxidizing agent. It oxidizes the other compound. That's why we are using oxidizing agent, but it itself undergoes reduction. Then, for example, if there is in oxidation, addition of oxygen or removal of hydrogen means the removed hydrogen is taken by oxidizing agent. You can remember like this. Then there are two types of oxidizing agent. One is strong oxidizing agent, another one is weak oxidizing agent. Example for strong oxidizing agent: acidified sodium dichromate or acidified potassium dichromate. These two act as a strong oxidizing agent. Then weak oxidizing agent, PCC, expansion is pyridinium chlorochromate, that is expansion for PCC. Then, so if you want to carry out the oxidation, you need oxidizing agent. Here, the heading is oxidation of alcohol. So, alcohol is the reactant. You know that there are three types of alcohol. First, let us take primary alcohol. Primary alcohol, when it undergoes oxidation in presence of acidified sodium dichromate, first step it gives aldehyde. Then it undergoes further oxidation. Aldehyde undergoes further oxidation, gives carboxylic acid. Here what you have to remember, the number of carbon atom remains same throughout the process. In primary alcohol, if you take primary alcohol having 3 carbon atom, means at the end the acid also has number of carbon 3. That is the rule for this reaction. Primary alcohol, on first step of oxidation it gives aldehyde, the second step oxidation it gives carboxylic acid. Then secondary alcohol. Secondary alcohol, on first step of oxidation by using oxidizing agent Na2Cr2O7, it gives ketone. Then further oxidation, it gives carboxylic acid. Here what you have to remember is number of carbon atoms not remain the same. If you start with number of carbon 3, the end is in the end number of carbon atom is 2. That is very important thing you have to remember. Number of carbon atom is reduced by 1 unit in the final product. Okay. But in ketone it remains the same, but on further oxidation you get carboxylic acid in which number of carbon atom reduced by 1 unit. So this is important point. Then in tertiary alcohols, they do not undergo oxidation at room temperature. Only at elevated temperature, and by using a strong oxidizing agent it undergoes oxidation. In that oxidation also cleavage of CC bond occurs, so you get mixture of carboxylic acid. Reactions are not given in our book, so no need to worry about tertiary alcohol, but you have to know this one: tertiary alcohols do not undergo oxidation at room temperature. So this one, for 1 mark you have to remember this one: cleavage of CC bond occurs, so mixture of carboxylic acid you get. Then let us go for example. First example, let us take propanol, CH3, CH2, CH2OH. This is propane 1-ol. What type of alcohol it is? It is a primary alcohol. You know that. OH, same thing. OH attached to carbon has 2 hydrogen atoms and 1 R group. So it is a primary alcohol. When it undergoes acidified Na2Cr2O7, what do you get? When this compound undergoes further oxidation, what is the product? Can you predict? Because you know the concept. Now you understand the concept. So what might be the product? Can you predict? This one is primary alcohol. Primary alcohol on first oxidation gives aldehyde. What aldehyde you get? CH3, CH3, CH2, CH2, CHO. What is the name of the aldehyde? This is propanol. 3 carbon atoms are present. Functional group is aldehyde. So the name is propanol. This is the first step. When it undergoes oxidation, you get the acid. There are 3 carbon atoms. What is the 3 carbon atom acid? That is propanoic acid. CH3, CH2, C double bond O, OH. Here I want to tell you one thing. How the oxidation takes place? You know that oxidation means removal of either addition of oxygen or removal of hydrogen. Here hydrogen is removed. 1 H from here, 1 H from here. So you get CHO. CHO. Then further oxidation. Here what happens? Here CHO group becomes COOH. Here there is no removal of the hydrogen. There is addition of oxygen. CH3, CH2, C double bond O, OH. CHO group becomes one C, 1 H, 2 oxygen atoms are present. So here addition of oxygen, here removal of hydrogen. So what is the name of this compound? It is called propanoic acid. Okay. I hope you understand this. Then let us take this compound. What is the name of the compound? This is, in this compound 3 carbon atoms are present. OH is attached to the second carbon. What type of alcohol it is? It is a secondary alcohol because OH attached to carbon has 2 R groups and 1 H. What is the name of the compound? Propanol. Propanol. Sorry, propane 2-ol. Propane 2-ol. Why it is 2-ol? This OH is attached to the second carbon. That's why it is propane 2-ol. Then this one undergoes acidified sodium, undergoes oxidation with sodium dichromate. You know that secondary alcohol on first step of oxidation you get the ketone. How ketone is formed? Oxidation is removal of hydrogen. 1 hydrogen from here, 1 hydrogen from here. So H2 is removed. So what is the product? CH3, C double bond O, CH3. Ketone. How many carbon? This is ketone. CH3, C double bond O, CH3. This is ketone. What is the name of the ketone? Number of carbon atoms 3. So propane. Then ketone means it ends with what? Propanone. Propanone. Then propanone undergoes oxidation in the presence of acidified sodium chromate. Sodium dichromate. You get CH3. CH3. Here what you have to remember, number of carbon reduced by 1 unit. The product is acid like primary alcohol, but number of carbon is reduced. Here number of carbon 3, here number of carbon should be 2. What is the acid? It is ethanoic. 2 carbon atoms are present, ethane, so you get ethanoic acid. Then using PCC, this is over. Then using PCC, what is PCC? Pyridinium chlorochromate. It is a weak oxidizing agent. If you use weak oxidation agent, let us see how the reaction takes place. This is propane 1-ol, primary alcohol, undergoes oxidation using PCC. On primary alcohol on first oxidation gives aldehyde, that is propanol. It will not undergo further oxidation. The oxidation stops here. It will not undergo further oxidation. That you have to remember. On weak oxidation, if you use weak oxidizing agent, reaction stops here. So I hope you understand this, the oxidation of alcohol. If you have any doubt, you can ask me in the comment section. Then if you like my channel, subscribe it and then put the like symbol. Thanks for watching.